Hey everyone, welcome to the 10th episode of the Coffee with Cosmos DB series. I hope all of you are doing good. And if you have missed to join our last session, you can watch the recording, which is available in the playlist. If you go to the YouTube channel, and then if you go to the playlist, you will be able to see the series. And then last time we spoke about one of the interesting topic about migration. Today we will be touching upon one of the other favorite topic for developers and also for the Cosmos DB users. And if you would like to know more about a particular feature or something that you want to share with the community, please feel free to reach out to me. Please make sure to subscribe the channel and share with the community members who are looking to learn more about Cosmos DB. Yeah, if you are willing to present or have any feedbacks, please share them in the chat or you can reach out to me offline. With that, let me introduce our guest for today. Today we have a very special guest to join us. To say he's one of my favorites when it comes to community. He's one of the community champion when it comes to Cosmos DB. So I would call him as the Azure Cosmos DB fanboy. Let me add him to the stage. Hey Subhashish, how are you doing?
Hey, hi, Ajay. I'm doing great. I'm
All
audible,
right.
I hope.
Yeah, I can hear you. Yeah, it would be great if you go ahead and introduce yourself.
Yeah, thank you. So, first of all, thank you for having me. So, I'm Subhashish. I'm a cloud solution architect at Microsoft. So, within Microsoft, I mainly focus on one of our large global, retail customers, and dedicatedly, of course, work on Azure Cosmos DB, and work with the teams on solution architecture, best practices, guidance, and so on.
Got it. I think today's topic would be very applicable to developers. I mean, we have been dealing with a lot of customers on a daily basis, but this would be very interesting to developers who are using our SDKs to access Cosmos DB. Yes, Cosmos DB being the database for developers. Today we will be talking about the query patterns with Azure Cosmos DB and the related concepts. So I think Subhashis will go through a set of demos and also he will share some of the best practices. I'm super excited for this session. Let's dive in.
Yeah, thank you, Saji. As you rightly articulated, see, since Cosmos is a distributed database, right, and developers are building their applications, there are certain set of guidelines which a developer or a senior engineer should keep in mind. Of course, it's an iterative process as you work, as you go along with it, right? You understand these best practices, you work with us, we troubleshoot them. But whatever we're going to cover today, are very important from a performance and price perspective, because one of the key USPs which we kind of and I specifically when I work with different let's call it dev teams focus on is Cosmos is one of those unique databases right on earth where you can fine tune your queries at a CRUD level, right, for a performance and a price perspective. So it's very imperative that you understand these query patterns and what we call about the anti-patterns and these best practices. What I'll do is I'll share my screen and directly we'll quickly jump into code and understand what exactly those things are.
Yep.
So is my screen visible right now?
Not yet. I think you. Yes.
So I have a Visual Studio 2022 screen in front.
Yep.
Correct. So one important point to kind of highlight here, which is very important, is though we're gonna cover .NET code today, C#, same principles apply to if you're using the Java SDK. In fact, in my day-to-day work, predominantly 90% is what we deal with, our account teams or customer app teams, basically who are on Java. But the same principles apply even if you're on the other SDKs. That is the first point. And second point is all the best practices guidance is same across all the APIs. So though we're going to talk about PostgreSQL API today, but the same best practices also apply to the other APIs as well. Some of the give and take, some of the method and the calls name would be different, but end of the day, the agenda still remains the same. How do you optimize it? So here, for example, as you see, right, we define the endpoint, the connectivity, we define a Cosmos client, we do the average generic things that we need to do. One very important question is, so Cosmos being a distributed database, right? We are replicating data across different, let's call it replicas, right? And then you have a quorum of 4 replicas within a region, right? You may have a multi-master with a single write region or different regions. It depends on your setup, right? So when you are trying to fire a CRUD, specifically to read operation, like we're going to focus on, right? So create is fine. You basically create a particular object, right? An item. So when you're trying to read, the fundamental point is why are you trying to read it? So basically you're trying to retrieve or seek, deterministically. So there is a property called atomic city, and we have something called determinism that allows Cosmos basically to determine which particular replica to go to, and seek that particular data from what we call the physical partitions. So very, very important concept, though. I'm assuming that folks kind of already are aware of this concept, but if not, but basically define a partition key. So you define what we call the logical partitions, and the data resides on lesser number or smaller number of physical partitions. Physical partitions you can keep or think in mind as basically as a combination of SSD slices with a compute and a storage, right? So that's very important. So you're basically trying to seek. Now in Cosmos there are 6 type of query patterns which a developer should be aware of when you are developing application using .NET SDK or a Java SDK, right? And these are, as I have kind of highlighted and I have written in the documentation, are from a cost effectiveness very important, from a best to a worst perspective. So we're going to deal with and we're going to see examples of all of this. So just to kind of cover these, point read is something which is a point lookup, which is the most efficient in terms of price to performance ratio, highly kind of recommended from Cosmos. If you have point read operations, you will always see, and you will see in action, right? It's always better than having just a query. Ideally speaking, again, we'll look at the nature of the point read, but best is if it's around a less than 1 KB size or 0.5 or 1 KB. 1 to 5 is something which is nominally okay. Anything above 10 KB, 50 KB, you should completely avoid and try and optimize, because the pricing of a one read of a 1 KB document, which we define as a 1 RU, right? It's on a 1 KB document. That's very, very important, and it grows linearly. There are times when you cannot do a point read. We'll look at what a point read is, but then you should fall back on what we call the impartition query. So when you're defining a query to read a piece of data, very, very important. If I can't do a point read, so you may think of a scenario, right? Then you should write a query, but then you should write a query in such a format that it becomes something called an impartition query. That means, what does it mean in simple English? It means that I'm telling the query engine, specifically deterministically which particular physical partition to go to objectively find out that particular database. Now then there are certain scenarios where your query will have multiple predicate filters. So those are basically, we call it in partition query with a couple of predicate filters. It could be quite a number of them, but as long as you specify the partition key in the query itself, again it will be treated as an in partition query. The query engine knows it won't do a full table scan. It won't do it, correct? Then there will be scenarios where you may not be able to do a point read. You may not even know the correct partition to go to. That means you can't specify the logical, or the partition key in the query. Then you are basically performing what we call a cross partition. And there are certain options you should be aware of, which we'll take a look at, where you can parallelize this cross partition query for better performance. That's very, very important to know. We have often seen, or we work with teams where they are unable to do that. It results in poor performance and cost. Then there will be scenarios where you are not having parallel cross partition query. Then can you basically paginate those results for better performance is something that you should be aware of. And then finally, usually we work with teams sometimes where you are not able to kind of, for a set of queries or a subset of your larger set of queries, where you're not able to specify the partition. Then it's technically what we call a 100% fan out query, right? Basically a select star from C is a perfect example. So it's going to be pretty expensive. It's going to be also non-performant in the sense. But before we move on and see some examples, some guidelines here you will see often in our documentation that we call it out, right? That one read of a 1 KB document is 1 RU. So write is a bit different. It's 5.71. Update is nothing but it's an addition. You will see basically you are creating and deleting. So it's 10.67 and delete is 5.71. So these numbers are very important to note because they deterministically determine when you're sizing for a workload on Cosmos. So, sizing is something which I predominantly work on with a lot of app teams in my day-to-day activity, right? When they're onboarding, they may be lifting and shifting from an on-prem database to Cosmos, or maybe from already on cloud to cloud migration, right? So when you're sizing it, these points are something which are very important to kind of keep in mind. Now, quickly, if I go down to, for example, what a point read is, and we'll revisit this, whatever we have covered here. So point read is technically a point lookup. So it's basically a key value lookup for a single item ID. But before we look at the code example, let's understand one method which is exists in .NET. So this is the one. So if I kind of highlight it, if you see the read item async, or in the Java SDK, technically it's basically a read item with a subscribe in Java. Now, why is it important? You have to understand this. So a point read kind of gives you, like you will see in documentation often, we have covered this, that it's very good in terms of performance and price. Why is it so? So there are three reasons why it is important. So what happens is when you define a POJO object in Java or a C# object, right? We cannot transfer that particular object via the network when you're making basically the CRUD call from the SDK. Let's say you're using, for example, if you scroll up, right, in the connection mode. So this is nothing but the direct connectivity that you have mentioned. So for the wire to be able to transmit this object, we need to serialize and then deserialize it once the object comes back. So basically, this particular item, read item async, right? This method, what it does three things. It first reads the object, it then converts the object into a byte stream so that it provides the SDK the ability to transmit it across a wire as a byte stream. And it also does something which is very, very, very important, which is the crux of this particular method, is it does a what we call 1:1 multiplexing call. So what does that term mean? 1:1 multiplexing call basically means at the CRUD from the SDK endpoint, it directly makes a 1:1 mapping with the physical endpoint on the replica on which the data resides. So we bypass a couple of steps in between. So it becomes a very fast, call. So once all these three things happen together, you will find it's a super fast call. It is very cheap and it is the lowest latency call. So let's see some code and example. You will see exactly where this is important. So for example, here basically I'm capturing the item response for a class food. For example, if I have a class food, right? I have the ID and the description, of name, tags. I basically three lists. I have nutrients, servings, and tags. So for example, if I kind of go to the account, so I have an items basically I'm looking at within a food collection container within a nutrition database. So let's say one particular object, 03226. You see, this is the ID, this is the description, the tags as a particular list. I'm capturing the version and food group. Now, very, very important here is the food group is my partition key for this particular container. How do you know it? Basically, if you go to scale and settings, as you can see here, basically here the food group is the partition key for my this particular container. So now going back to code, now this is why is this very important. So if for let's say I want to seek that particular item, so I basically capture the response. Then within the container object, this is the most important part. You will find there is a read item async. What is read item async? Basically is it takes the food class, then you have to mention the item ID. For example, here if I go back to this particular screen, so I take this particular ID. Partition key basically is the base. So food group value. Please remember that this is not the food groups that you type in. Food groups is the partition key, but the value has to be passed here. The foods is the value. So basically, if I go back here, see, baby foods is basically the way I have partitioned the particular container. So you have the poultry products, you have different other items listed in this particular, So now very important for this to understand is, of course, I capture the object with the response, and very very important is a good practice, and this is one of the points also we'll discuss later. Is good practice is for these type of operations, you should capture the request charge property. So this is nothing but it gives you the measure of the units, the exact request units that you're spending for this particular execution to happen. Now here, one important point is, for example, if I basically just add a breakpoint, let's see, I will add a breakpoint here and execute this. So let's, for example, execute this and we'll quickly see the output for this so that it's very clear. And then we'll also capture and execute the same thing specifically from the portal. So if I go backwards, as you see, this is an example of a point read or a point lookup in Cosmos for a specific item. So what is the ID? I'm looking for 0326. So what is the ID? Very, very, very important. And this we will extrapolate to very large use cases, voluminous use cases where you are firing millions of queries. So this is 1.33 RU per sec. What is the document? So let's say I go back to code. So our best given SL, if I delete this endpoint, is one read for a 1 KB is 1. So you are only a little bit more than what Microsoft specifies under certain conditions. Of course, there are certain library conditions, laboratory conditions under which this one RU is generated. So your 1.33 is pretty good, not bad at all. So as you can see, right, this is a bit different from firing the same query using a query format, which we will do now, and also versus the portal, because this is one of the related questions which I often get in some of our sessions that, hang on, I basically can write this point read. How can I basically write it in terms of a query, or rather the vice versa? People often basically do a query format for the same. For example, I can fire the same output of the same object where I'm doing a select star from C, where I'm passing basically the value for my partition key. So I'm making this particular query in partition query, and I'm passing also the ID. It is exactly the same, correct? Now, very important, I will basically add a breakpoint here, and we will execute the same query. So now we had a point read which was 1.33. So basically, I'm doing item async lookup for a particular item, and now I fired the same output. So if you see select star from C, where C dot food group is baby foods with C dot ID, same ID value, it's 2.8. The output is the same, but as you see, the difference in the RUs is pretty like observable, right? So it's pretty practically two times, like 2x or 1.33. If I kind of round this up and make it like a 3 RUs. Now, question comes up is the value different if I fire from the port? The answer also is yes. For example, if I take the same query, for example, let's say I will take select star from C. I go to query one where I have the same query, and let's say I will fire select star from C where C dot ID, and I'm basically giving the food group result. So I have basically the same output, same one document out of the 100,000 documents that I have. But if I compare the statistics, if you see 3.03. So very, very important point to understand is from the SDK, it was 1.33 because I was doing a point read from the SDK, but a query was 2.89, and the same output from the portal is 3.03 because more buffers are getting added, right? More layers are getting added. So the layers are getting more added means basically you are incurring more cost, and also in terms of latency, higher latency. Now, one very important point to kind of objectively note here is, which is again a good practice on approaching cases, is if I have use cases where I'm having queries quite a bit, can I kind of convert them into point reads is a good point to note here. So this is something which objectively you can do for a certain maybe parameter sets. This on a day-to-day basis when we work with our app teams has benefited them quite a lot in terms of cost and performance, because if you see 1.33 versus let's say 2.89 RUs, and let's say now you multiply both sides with 1 million, that's like correct operations, right? And you multiply this cost on the same output parameter, you are talking about quite a lot of dollar values. These RUs get converted to dollar values, right? So this is something which is very, very important. If possible, use the object serializer, deserializer, as much as possible, rather than having flat in partition for the same output where it's objectively possible. But there will be some cases where you may say, you know what, I do not know specifically the ID. Where maybe I'm writing a query like this, where I need to basically do an in partition query where I'm selecting for description, manufacturer name, servings. But I just know the what do you call the value for my partition. How is this query treated? Again, it will definitely be fired. It will be an in partition query, but because you have multiple predicate filters, right, it will be much more expensive than the in partition query having just one particular ID. So, for example, if I kind of run this, it is important kind of to objectively view. So, for example, let's say We establish connection. I have a point read for one particular document, 1.33. I had query for the same document, not a point read. I had 2.89. And then I had a query which basically have three different filters, basically, and where I am searching across three different columns, but I'm having only one particular filter, but it will be treated as an in partition query. But it's, as you see, the difference to 2.96 argues is for this particular query. So one here best practice to do is when we work with teams, we strongly recommend that if you are building a use case, whether it's a greenfield or migrating from another database to Cosmos DB, you should have an idea of read versus write heavy patterns. And within the read, specifically top 25 is good. If 25 not possible, top 15, if not possible, top 10 queries. You should note them down at the query level. Have an objective view of how much argues that particular query is gonna suffice to give you the best results. Of course, and then of course you can iteratively work with us to do a stress test on what is the max QPS. So if this particular query I take for 3000 QPS, what's the best kind of price to performance ratio I can get. That gives you at scale the volume at volume. What is the cost that you will incur? What is the performance you'll go down to, right? In milliseconds. Is it, if it's 20 milliseconds, can you optimize a few parameters in code and make it 10 milliseconds? I have seen 2 milliseconds even at 3000 QPS. By the way, we have worked with teams where you optimize code so much. But why is it important? Because you have to go down to the depth at this level. Then only it makes sense to kind of optimize at this particular level. Now, very important point is, let's say I have a query, I have a lot of what do you call filters, basically. So definitely it will incur more cost because you, of course, have a few parameters where you are going through and, for example, featuring, for example, is defined, right? For example, you are passing different parameters and you are capturing these outputs. You will find these results, definitely will be captured. You may have, definitely a little bit more latency and on the cost side. A very important question is, for example, I have two and filters. Like, for example, does it matter if I change? Like, this is a common question that I get, the order. It does not matter as long as your, in partition query is there, as long as I mention let's say, the value for my partition key. That is very, very important. It will be treated by the query engine as an in partition query. This is very, very important to understand and note. And of course, you can tweak the different parameters and say there will be some sub cases where the order is important. For example, if you're doing order by and all of that, those then are certain exceptions to the rule. Very, very important is I may have, and we work with such teams also. By the way, here there are certain things we kind of mention. There are certain links, by the way. For example, in partition query, there is a link mandatory read. This particular document, like how to query container in an in partition query. This is a very good, strong recommended read. And there is one particular document at the top. I think it is mentioned, yes. So this was published in our dev blogs, point read versus queries. This is a mandatory read for all developers. It gives a perspective view and a mathematical also kind of a view of the different output numbers of doing the same operation, like example I showed, point read versus queries. It is highly recommended that you kind of read both these two posts as well. Very, very important point is, let's say I have certain use cases where I may not be able to do 100% in partition query. That means I may not be able to tell the query engine that, precisely go to this particular logical partition and precisely go to the physical partition, the data inside. What happens then? Now, of course, it's I would call it not a very bad pattern, but technically, speaking in Cosmos, you should avoid as much as possible doing cross-partition queries. Correct. So because the query engine does not know which partition to look to, so it kind of goes to different indexes to check whether it exists or not. So, for example, this particular query, and nothing wrong with it, but I'm selecting all from the container. I'm just mentioning one particular parameter C version, but do you see anywhere the partition mentioned in the query? The answer is no. So for Cosmos, though it's a simple lookup only for C version values, it will be treated by the query engine as a cross partition query because the query engine does not know which particular logical partition to go to look. Then it only scans the index, basically seeks right from a table to check the different pointers to the partitions, actual data resides. So this will definitely be what we call a query fan out operation. If you execute this, you will find it's pretty expensive, and also it may take some time for you to execute this. Latency will not be that good. That's an example of cross partition query. Again, coming back to the point, multiple cases we have seen folks inadvertently using cross partition queries. Why? Because they mentioned everything, but they are not able to scope or precise logical partition. So that is something which you should 100% avoid as a practice in Cosmos DB. And this particular fundamental holds good across all APIs, across all SDKs, and in fact, if you have worked even with other databases, right, across all distributed databases, this particular concept holds true. Now, there could be certain cases where you are having a cross partition query. There is no way. That means your business case is such where maybe 90% are point reads, 5% are in partition queries, or that remaining 5% where you have to do for your business case cross partition query. Maybe some upstream data is coming to you, or downstream data is being fed to you, where you are feeding to someone, where you need to do some cross partition query and give a data at a very high skew level. So then, does the SDK provide you any ways in which you can optimize it? So we basically call it efficient parallel execution. Both .NET and Java gives you same set of features. In Java, in fact, there is one additional more feature. In .NET, you can definitely look at parallelizing this particular partition. So there are three particular properties that as a developer or a software engineer, you should be very, very aware of. Again, we often see teams not parallelizing these cross-partition queries for performance. So what are those? Very, very important. So in the code, for example, you see I'm using the concept of pagination because this particular select cst.id manufacturer name, where the manufacturer name is not null, will give quite a bit of data. And you see anywhere the mention of food group value? The answer is no. That means that this will be treated by the query engine as a cross-partition query. Now, I can just execute and fire it. It will be a big hodgepodge of a lot of output. So how do you kind of mention these particular features? So in the query request options is where you mention these particular features. So one is the very important max concurrency. So it defines the number of concurrent operations to be run on a client side during parallel query execution. This is very, very important because it sets you the maximum number of simultaneous connections. In case you are unable to decide, the number of parallelism, you should then do -1. That is the safest bet, as you see in my code. That basically tells the SDK, you know what, why don't you define based on the container layout of my data, on the number of partitions my data is lying, why don't you determine the best parallelism value? If you set to 0 by mistake, often we see it that happen, then basically you are telling, you know what, please fire only a single network connection to all my physical partitions. That's a bad thing to do, right? So either you mention it to number of physical partitions, so there is a way to know. You can go to the portal or even look at log analytics. You have activated it, the number of physical partition layout, and you can fire that number of concurrent connections, or just be safe, define -1. Very, very important. Max buffered count, again, very, very important. It is basically gives you the number of items which are buffered during the parallel query execution. Very important that if you kind of you can mention. If not, then best is recommended by the Cosmos DB services. Put it as -1. The SDK determines it for you based on the use case values and the amount of it basically runs a query plan. In the query plan, it picks up the output being offered, and then it basically determines the value which is best for the execution of this particular query. Item count is nothing but the number of items which you want thrown as a page in a particular iteration, or we call it an enumeration, right? So you can specifically fix it with a particular number, or in case you don't want, you can definitely give a -1, which is for the dynamic page size. So this is the maximum, by the way, of -1. You should not go below that. So for example, here, in my case, I basically defined 100. That is basically, it gives you, max number of items to be returned in this particular enumeration. So here, for example, if I run this, let's see some output. So the first one is the point read, very, very important. Predominantly, again, Azure Cosmos DB, why is point read so important? And we spoke about it. If in a use case, you can fine tune your queries so that predominantly you are having a CQRS pattern where specifically for read and write, you have different, data stores. And for the read, if you can have within CQRS a sub CQRS pattern where you are having predominant point reads, it's the best way you can utilize Cosmos, for very, very low latency at a very high volume, very high burst scenarios. Like amazing results you can get. Then query, for example, select star from C, like for example, as you see 2.89, and select star from C, where C dot version. This was, guys, remember, a complete 100% full table scan. It's like select star from the entire container because my query engine has no clue which particular logical partition to go to. So look at the absolute hopeless number. This is 20, this is 1.33, you have jumped to 91.49. And this is still very low because I have like what 500,000 records in my container. We often work with customers who are terabytes of data. So if you have something like 1,000 physical partitions, 2,000 physical partitions, you will see this 91 RUs boom up to maybe 400 RUs, 900 RUs, or 3,000 RUs. It will be like totally burning your cache, right? So you have to be very, very objective about a particular execution. So here, as you see the pagination, the page comes through, and basically because there is a output, the query operator kind of defines the data, and then it basically. In fact, if you see, I ran so much of data, it basically gave me page 17 particular pages of data, but still the value is lower than a full table scan. This is very, very important to note. That means technically my previous of a full table scan, where I was still looking for that overhead added and basically made it higher in size. So why is this more? It's a good logical question, right? That I did a full table scan. It is lower than this. Why? Because there is an overhead added to just then after the entire C search, my index had to figure out where this C version sat, and basically added more overhead to the already added overhead, and then resulted in 91.47 RUs. So this is a perfect example to show that you should prevent doing from as much as possible full table scans. Uh, Now, if we go back to full table scan is what basically select star from C, right? You saw it's a very bad way of kind of optimizing it. So this is something which you should be kind of aware of. And one very, very important summary of best practices. I mean, we can discuss different points around it, but I have kind of noted these down as practices that we kind of work when we work with teams. These come iteratively. I mean, it's not that it's a list has to be followed. Of course, we have a list of performance tips query, a document which is already shared. Maybe I will kind of open this particular document and little bit, kind of. So this exists for C Sharp and also for Java. You're more than happy to kind of execute this to Java as well. So basically what it does is it gives you the different query. For example, this you can optimize for a 64-bit only. It basically uses a local query plan execution. This we spoke about, very, very important. Please use, single partition, definitely, queries. Avoid using the iterator unnecessarily. This is something which is very important. So if you have query results consumed by current component, make sure that you don't recreate the iterator again for the continuation of every page. This we spoke about degree of parallelism, very, very, very important for a cross-partition query. You can definitely fine-tune the page size and size. We spoke about all these things, but very important is again you don't have to keep it as a checkpoint. But how do you? So now question comes up here, Saji, is very important. Is let's say I'm a new developer into the service. Right now, I'm working with a few teams who have recently got onboarded to Cosmos. They have come from let's say Oracle on-prem. So what is that thought process I should have to keep in mind? First is know your use case very well. Is it write heavy versus read heavy? If it is so, then how better can I implement something like a event driven, CQRS pattern is what Cosmos is kind of gives you very good results on. Very important is then for a given use case, let's say the read I'm now focusing on. Let's say within that particular CQRS and read, can I do point reads as my key query pattern? Very, very, very important question. If like we have worked and saved millions for those who have just moved their existing in partition queries to point read because of the number values differences we showed, right? So if it is so, then maybe you should focus on optimizing your code for point reads. At times when you can't have point reads, then we will talk about the in partition queries. Now, here for the point reads for specific operations, make sure again, very, very important, you leverage the correct pattern. What does that mean? So this is a sub discussion point. Like for example, we often work with teams where they say, you know what, I have point reads, but I have multiple parallel point reads that I need to. Should I fire multiple point reads or Cosmos has something which can help me for this particular pattern, please reach out then to Microsoft or folks with whom work with. For example, we recently optimized code for some apps, the teams which I work with, right? So what we did is we have something within which we call the Readmany API. This Readmany API, again, there is a good documentation around it, right, on our blog. It helps you optimize point reads in a parallel fashion. So this is a sub pattern to the point read pattern. You should be aware about these, right? It will save you cost, time, and low latency. Very, very important. If you are trying to push through 3,000, 4,000, 10,000 queries per sec, and let's say your turnaround time is less than 10 milliseconds, 6 milliseconds, can I optimize it to 2 milliseconds, 3 milliseconds? By the way, such use cases basically work with one team, right? Their on-prem was 1 to 3 milliseconds, and Cosmos at 3,000 within 2 milliseconds. How did we optimize? These were all the tricks, right? Then very, very important, can I replace bulk of my query with point reads? This already I discussed. But then there is something called, which is a sub pattern or a discussion to this, which you will see a lot of documentation around, even on blogs you will find, is something called diagnostics property. Leverage the diagnostics property for optimizing the different transport layers the code is going through. How can you optimize it? It gives you the request property charge also, right? So you can optimize that particular query, queries into point read. So optimize for speed and cost of execution in the query then becomes very vital, because in point read it's already the object serializer which takes care of all the design to bother. But in query it is up to you. How can I find you in the query? Then in the single partition query, now when I'm down to queries, you have to mandatorily be able to use partition keys. Now again, it's a sub discussion point here, quite a large discussion we can have around this. I often work with our, of course, Microsoft Cosmos DB engineering teams along with client teams, right? Where there could be use cases where upstream and downstream you have dynamic data coming in. It is not possible, not feasible, very difficult to kind of define a partition key. Then maybe you can create certain emulation algorithms or enumerators, right, where you kind of have a very dynamic or a hierarchical partition, synthetic partition key, where it kind of gives you a structure so that at least some elements of my queries I can reconfigure in a single partition key. In fact, in Microsoft, we now have the hierarchical partition key, right? We'll cover it in one of the future sessions on this particular, Coffee with Cosmos series, which is very important because partitioning is a whole gamut and a whole discussion, deep dive in its own. But it becomes very important when you're defining this single partition query, because if you take a real life example, there are times when partition queries are not simple, they're very complex. So how do you kind of optimize it? Something is the best practice we should look at. There is enough documentation around it. Diagnostic property, as I mentioned, highly recommended. All developer teams who are highly optimized on both cost and performance and at scale. Scale means 3,000 QPS, 5,000 QPS, 10,000 QPS with turnaround time of milliseconds, not seconds. They, invest more time in optimizing code with diagnostics property. Very, very, very important. Please check out. There's enough documentation available. And then, of course, you can convert cross-partition query into in-partition as much as possible. And if you can't, then how do you parallelize it, right? These are some of the things, kind of a summary of best practices. Sajid, we kind of covered pretty much a lot of it along with, some practices.
Yeah, I think it was very interesting. You didn't give me a chance to actually ask questions. I think you covered in a way such that it's very relevant to the audience with questions, and then how to handle each of those situation and the difference and the best practices. So yeah, it's very interesting to see. I do have a couple of questions from the audience. Maybe we
Yes,
want to
please.
proceed. Yeah, the first one is, I think this is on the RU consumption. Can you elaborate more on why should there be a difference on portal versus SDK? As a customer, he would like to understand how much RU consume. Basically, so the concern here is whether they have to always write a code to understand what is the minimum RU for that particular operation, point read. So
Yeah, so see, the recommended I would suggest is, for example, if I kind of break this down, it's a good question, right? Even we have this discussion with app teams, right? So
yeah,
if you're trying to objectively as a developer, so let me write this down. So let's say I'm an engineer and I'm sizing it, correct? So when I'm sizing means I have to give to my management, let's say, a prospective price and a latency performance. So, and I'm objectively doing a study, or rather, let's say, two ways I'll break this down. How I have seen teams do subjective study. Suggestive study means, it's a tentative pricing. I'm running XYZ amount of queries in Oracle on-prem versus I'm doing a comparative study on cloud. Then do I 100% need to kind of always come to SDK and find? The answer is no. You should be good with Azure portal and the our Azure pricing calculator for a kind of a subjective pricing, that what is 100K, for example, on-prem cost. This will cost me, like, let's say tentative 75K at a certain amount of queries for my peak usage. Like I've
Got it.
seen teams do that. Then portal is perfect because in the portal, basically, it's not an SDK call, right? There are certain layers added to my call, so it will be little inflated on the side, but it won't like majorly impact you. But let's say now you have decided on Cosmos, but you are now having an objective engineering study. That means I have a predefined use case and I'm doing a POC. Like I work with teams, right, where I have two SLAs I need to meet in my pilot. What are they? At, let's say, 3000 QPS, I need to have for my bulk of the pinpointed query a 1 to 3 millisecond turnaround time, because my, let's say, downstream app requires this. So if I am 5 milliseconds here, the pilot fails, or at a 3000 in place of 3000, if I go to 2000 but I'm at 1.3, still it fails. Why? Because I'm not able to push 3000 queries. This kind of a pilot, if you are doing, or a study, if you are doing from an engineering perspective, and let's say this is what we call a tier 0 application, very, very, very mission critical for your app. Let's say finance apps are added to it. You're building something for finance, or you are a hedge management firm building something on real-time portal analysis. Then you are strongly recommended not to do this subjective study, but come down here, create an Azure subscription with an account, upload a subset of data. Let's say I have worked with teams who have only uploaded 10 GB of data, then wrote their top 3 queries, which subjugate to this particular pilot. Then work with us to get, can I go to even 3005 QPS? And we found out, let's say, 1.5 millisecond is the best time we are getting. So still I'm failing, right? Because I'm not meeting this, the 1.3. Then can I then basically lower this down to 3000 QPS? And basically then, I kind of reach to maybe 2.5, which is between 1.3. But then this study, 100% strongly recommended is to use the SDK. You will not be able to do this in the
Got it.
portal or using the REST API. This can be done via the portal or the REST API also. We forgot to mention that. The REST API also gives you the result, but not for an objective engineering study. This is very, very important.
Yeah, I think that's a very good answer to differentiate when to use what. I hope that answered that question. So there is another question. I hope you already covered this one, but correct me if I'm wrong. If I use a simple query and read a single item, then using point read is a good option and cheaper than queries. Yeah, that's something that you already explained, right?
Yes,
Yeah.
200%. And as objectively showed the difference you saw in it
Yep.
yourself, like 1.33 and 3.03 on my portal versus 2.89. So we had captured this, like, is
Yeah,
quite
sure.
a lot. Because don't think it, and that a mistake sometimes developers do is when I discuss with them is, hey, man, it's just 2x. But don't look at 2x. Look at now multiplying this with 1 million. For example, there are certain cases where we work with 10 million requests burst. So if you
Yep.
multiply this 10 million, it's 10 million RUs, and this will become 30 million RUs. That's massive.
Yep. Makes sense. All right. I think I have a couple of more questions relevant to what we discussed. So I think you
Yes, please.
covered the best practices. I hope these principles that you mentioned, those are applicable to Java SDKs as well, right? The V4,
Yes,
the latest. Yeah.
yes, yes. In fact, the Java SDK gives you more like output from the diagnostics property. It's much
Got it.
more mature because of the Java, itself only. Otherwise, the principles apply across all APIs, across all, SDKs.
Yeah, and the other question is that since you have been dealing with customers and their production workloads, in real life scenarios, like what is the best milliseconds level latency for point read operations that you have seen in a high volume cases? Yeah.
So see, I worked with a lot of volumes which are high, like high volume, high burst, because of the retail scenario, right? So for
Mm-hmm.
a high volume, what we call, sudden burst. So an Xbox sale opens up. So there's a huge pile up of queries, right? I have seen in Cosmos it's possible if you have a very highly optimized like CQRS, basically, pattern. container with quite a few, even terabytes of data, in which you have multiple like physical partitions on which this data resides on. If you have a highly point read optimized, I have seen at least till 3000 QPS. That means 3000 queries are getting executed, and the turnaround time, the seek and that object to come up, and then we've been able to give it to the downstream in around 2 milliseconds. That's the best I have seen in life.
Got it.
100% possible is in Java, but then they should be full, with publish on, subscribe, and all of that. There are a lot of
Got it.
doing things here on publish on subscribe, so those things have to be taken into consideration. It is both the reactor, kind of output.
Got it. I have one more question from the audience. Like Abhishek is asking, if I have large amount of data, then the point read is good option for it or not?
Sorry, once again, can you see if I have a large volume of data?
Yeah, whether the point read is a good option or not. I think it depends, right? So that's the whole point of this session. So probably,
Yeah. Because see, the objective answer would be, irrespective of that, it should be good. Because when you use this particular object serializer, deserializer, right, it bypasses a few internal steps. So out of that, one is a lookup at a master partition table and all of that, right? So it automatically goes, it does that multiplexing and quickly goes to that physical partition in which the data resides. Having said that, but that assumption of a good read item async, that 1.33 RU, or that our mathematics of one read of a 1 KB document comes up in a 1 RU, is that you do not have a high partition or a poorly partitioned database. That, of course, assumption is there. That means you have a good consumption ratio on the underlying physical partitions. That is definitely there. So your data may be massive. It doesn't matter, because in that 2 milliseconds, which I told, the best I have seen at 3000 QPS data was quite a lot, but it was highly optimized per physical partition. It was not that some physical partitions are full of data and some were totally lying idle with like hardly 1000 request units utilized. That was not the case. Data has to be uniformly distributed.
got it.
Because
one final
here,
question. Yeah. Go
yes,
ahead.
Aji, because I will mention here one very important thing, which often people kind of ask this, that under what conditions is this one read of a 1 KB document, which is one RU there, or is it universally true? The answer is it's not universally true. There are certain conditions under which that particular thing happens. And one of the conditions is that you do not have any data skew. Very, very, very important point. Correct. So your data and how it's laid down is also plays a vital role in getting awesome, latency.
Yeah.
Yes,
I know that we are on time. Like one final question, right? Today we covered on query patterns, and that was very useful and probably the most interesting session that we had so far in this series. So this query is related to the choice of partition key. I think you talked about different patterns that we have on Cosmos DB, including
Correct.
a hierarchical partition key. I know that we have to cover in one of the future sessions. Any guidance around the same in summary? Like,
see, again, it's a big topic in its own, to be honest, right? Partitioning is a big topic of its own, but keeping it very simple is, for a read operation, if an individual or an engineer, when sits down, has to have a prospective or a subjective idea, again, not objective, but a subjective idea what they are querying for. Can I capture the most commonly occurring predicate filter? Ideally, that should be your partition key. That's the summary of it all. But then there are certain use cases which are edge cases. That's where the complexity comes in, where I need to have high cardinality, where we will talk about, right? Because high cardinality means the number of logical partitions increases. That means I have a more lower chance of getting into a hot partition scenario and all of that. So introducing cardinality, introducing more uniqueness and all of that, right? Those are the sub-edge cases. But as long as if you are able to define the most commonly occurring filter predicate, ideally that in your queries should be, or that should end up in your particular container, a partition key. And again, as I mentioned, for all distributed databases, including Cosmos and all other databases that exist on Earth, right, all distributed, if you can follow, again, not mandatory that you have to follow, but if you can follow a CQRS pattern such that for a given container or a collection, for your item sizes, my most commonly asked is my partition key, is you are in the best situation.
Mm-mm.
If not possible, then are those edge cases we'll talk about, right? A synthetic key, hierarchical partition key, and all that.
Got it. Okay. Yeah, thanks, Subhashish, for all the insights and also for the wonderful demo with step-by-step instructions. I know we are on time, so uh, thanks a lot who have joined the session um, with all the questions that you have asked. Thanks for those. And then before I close, make sure to subscribe the channel and please provide any feedback you have. And if you want to hear about a particular topic, um, yeah, Subhashish, we would like to have you in another session soon. But thanks again for joining. Um, we will meet again in a couple of weeks. Next time, we will be talking about another interesting topic. Yeah, see you guys.
Absolutely. Thank you, Saji. Take care then. Bye.